I'm Don Hillman, a retired professor from Michigan State University. During my retirement, I have assisted farmers in over 100 stray voltage cases and have studied electricity extensively. Electricity is a blessing to mankind when carefully managed and when its effects on the body are understood and respected. But like alcohol, drugs, and tobacco, when electricity is not properly controlled or people are overexposed, electricity can cause human and animal health problems. In 2003 and 2004, I discovered uncontrolled electricity, so-called electrical pollution, in homes, schools, and workplaces in East Lansing and other places in Michigan. The objectives of my presentation are educational. I will define electrical pollution and identify known causes and sources, explain known hazards of electric pollution, show how electrical pollution affects electrical equipment and health of people and animals, identify ways to monitor electrical pollution in your home and community, and show you ways to protect yourself and your family from electrical pollution. Much information about the effect of electrical pollution is available in books, hundreds of articles in scientific journals, and on the internet. Yet very little is reported in the news and nothing is taught in schools. We are 20 years behind our counterparts in Asia and Europe in understanding the harmful effects of electric and magnetic fields in the living environment. Because research in universities depends on grants, the money is spent on developing new electrical devices and medical treatment, and very little on prevention of electrical effects on human and animal health. To help you understand the remainder of this presentation, I will first explain a few key electrical terms. A conductor is an object or a substance that provides a path for electric current to flow. Conductors shown are the overhead lines, the air, the earth, the metal fence wire, and the man. Voltage is a measurement of the electrical pressure that forces electricity to flow through a conductor. The size of the desired voltage depends on the size of the workload to be accomplished. In this illustration, we see a voltmeter measuring the volts from a test wire underneath the 46 kilovolt transmission lines. Current is the amount of electricity that flows through a conductor. The current is measured as amperes with an ammeter, as shown in this illustration. Current is sometimes compared to gallons of water per minute that flow through a water pipe or the current of a river. Ampere is a measure of the number of electrons flowing through a conductor per second. Current flows from the electrical utility power station throughout the countryside and returns to the substation by way of all conductors, including the metallic wires, the earth, the air, water, all animals, and man in its path. Electric and magnetic fields, EMF, radiate electricity from conductors. The electric and magnetic fields will vary in strength and direct correlation to voltage and current on the conductor. We can measure the strength of these fields with a Gauss meter. The plume of invisible lines surrounding the conductor are called the corona or crown. The intensity of electric fields is measured as volts per square meter. The magnetic field is measured as amperes per square meter. Inferior quality power is distortion of the normal 60 Hz waveform and causes pollution of the electric supply. Harmonics are frequencies greater than 60 Hz. Transients are short duration voltage spikes. Sags are voltages 5% less than normal or nominal. Swells are voltages 5% more than normal, and surges are short-term high voltage transients. They all contribute to electrical pollution of the environment. Frequencies other than 60 Hz are called electrical noise. This is a graphic presentation of the voltage waveform depicting alternating current, AC, which is the electrical supply used in most of the world. From the left side, you will note that the voltage waveform starts at 0. The voltage reaches its positive peak at the upper red arrow and declines past 0 to a negative peak at the bottom red arrow and returns to 0. This is called 1 cycle or 1 hertz. The power company generator produces 60 cycles per second or 60 hertz. Harmonic signals are whole number multiples of the fundamental 60 hertz waveform, as in this illustration. The first harmonic is 60 hertz frequency. The second harmonic, 120 hertz, is shown with 2 peaks compared to the first harmonic. Then a third harmonic with 3 peaks, 180 hertz. A fourth harmonic with 4 peaks, 240 hertz, and a fifth harmonic with 5 peaks, 300 hertz of frequency or cycles per second. Harmonics can contribute to electrical pollution, causing electrical equipment to overheat or malfunction. A transient is a rapid voltage or current spike that occurs on the waveform. The spikes are usually of short duration, but may be very high voltage, as with a lightning strike. Opening and closing of switches and discharge of capacitors on power lines also produce transients. Linear loads have a uniform voltage, frequency, and current draw. They produce no distortion of the waveform except when a switch is turned on or off. Light bulbs, electric heaters, and motors with a constant charge are examples of linear loads. Prior to 1972, most electrical loads were linear. That is, they operated on normal, utility-supplied 60 hertz sine waves, alternating current. In the grounded Y distribution system used throughout North America, the unbalanced current should return to the substation via the metallic neutral conductor, the lowest line in the photo, provided the neutral is of sufficient size and designed to handle the types of current loads it will be required to carry. Since the early 1970s, we have seen a dramatic increase in the use of modern electronics, which are nonlinear loads. Nonlinear loads change alternating current to direct current. Direct current is current which travels in only one direction, as from a battery. Electronic devices change the frequency of AC current to speed up or slow down a process or signal. Variable speed drives switch mode electronic devices such as copy machines, MRI or magnetic radiation imaging, TV, cell phones, digital clocks, radios, some types of halogen fluorescent lighting ballast, and load switching capacitors on power lines, and hundreds of other electronic controls use nonlinear loads and contribute to electrical pollution. With nonlinear loads, the computer, TV, and so on, the neutral current can be 225% of the highest phase conductor. Notice that A, B, and C, the phase conductors, are carrying 20 amps each. The neutral, which is supposed to return the current to the substation, is 42 amps, or 225% of the highest phase conductor. With nonlinear loads, the majority of the neutral current flows uncontrolled over the earth and in the air. Now we have the earth and all the surrounding environment contaminated with dirty electric current. Neutral to ground wire contamination is the #1 source of electrical pollution in North America. Not so in Europe, where they do not permit the neutral wire to be grounded to earth. A second source of electrical pollution of the environment is emanating from communication cables, such as the 8 bundles of cables attached to utility poles on Bertram Drive in East Lansing, Michigan. Here we have 2 3-phase transmission lines, a local distribution line, and 8 communication cables on the same pole, each radiating electric and magnetic fields into the environment. A third source of electric pollution is the high power transmission line. Current is radiated for several hundred feet from these 3 46 kilovolt transmission lines on the Chick Farm near Leslie, Michigan. Electrical appliances, office equipment, and hundreds of electronic devices are a fourth source of electromagnetic pollution in homes, schools, and workplaces. Wireless communication towers are a fifth source of electrical pollution. Concerns about effects of uncontrolled electricity in our community began after Nextel installed a cellular telephone station at the water tower in the city park near our home and across the street from our elementary school. Then, 4 years later, Nextel applied to the City Council to expand their cell phone installation in the park. Neighbors became concerned about effects on health of families in our community. Dairy farmers were first to recognize that uncontrolled electricity affected behavior, health, and milk production of cows. I had worked with dairymen, veterinarians, extension agents from Michigan State University, electricians, and electrical engineers conducting research and attempting to understand the problems. Dr. Martin Graham, Professor Emeritus in the Department of Computer Science and Electrical Engineering at the University of California in Berkeley, and Dave Stetzer, industrial electrician from Blair, Wisconsin, measured ground currents between front and rear feet of 6,000 cows in Wisconsin, Minnesota, and Michigan. Charles Goke from Mason, Michigan, and I analyzed and summarized their data and had the statistical analysis performed by Drs. Van Horn and Dr. Wilcox, dairy scientists at the University of Florida. Stetzer videotaped foot movements of cows in Wisconsin herds and found that cows moved their feet in response to ground currents appearing on the oscilloscope screen. Thus, voltage or current from the concrete floor was causing the cow to lift her feet to avoid the shock. This cow in mid-Michigan was dancing to wireless currents from the earth or from the air. She was standing on the floor and not touching any metal, while voltages passing from front to rear and left to right feet were recorded via oscilloscope. Foot movements per minute increased as voltage potential between feet increased. For each minute, voltage was recorded. This outstanding dairy herd in central Michigan was dancing because uncontrolled electricity on the ground wire was traveling through concrete and metal stalls, shocking cows and interrupting the milking process. The problem was solved when the utility was required to move the transformer pole out of the barnyard and a neutral isolation transformer was installed between the utility and the dairy farm electrical system. Then the cows stopped dancing and herd improvement continued. The muscle spasms on these cows were related to electrical spikes from ground currents that appear on the oscilloscope screen. This is muscle and skin fibrillation. Note that the spasms stop when cows lift a foot, breaking the electrical circuit. These calves were dancing, and the skin and flank muscles were shimmering from electric shock from uncontrolled ground currents on farms in Wisconsin and Michigan. This is wireless electrical shock. These horses were shimmering from stress of electric shock delivered by currents flowing through the earth, returning to the substation, through the pasture field, and the horses. Here we see skin and muscles fibrillating when peripheral nerves were stimulated by currents passing through the earth and through the animal's body. EMF affects cows. Behavior, health, and milk production studies were conducted with dairy herds in Wisconsin, Michigan, Minnesota, and Virginia. New discoveries were that power lines delivered dirty electricity. There was no previous reference to power quality in agricultural literature. Distressed cow movement increased as voltage on the floor increased up to about 1,000 hertz. Milk decreased as the third, fifth, seventh, and tripling harmonics increased. Cows were affected by wireless currents. They were not touching metal. Total harmonic distortion exceeded IEEE 519, 1992 recommended limits. A similar study was undertaken in Quebec, Canada, in their dairy laboratory. Investigators found similar results. Cows were exposed to 10 kilovolts per meter electric field and 30 microtesla magnetic fields equal to standing under a 375 kilovolt transmission line. Milk decreased 5% in 28 days compared to no exposure. Fat-corrected milk decreased 14% compared to no exposure. Milk fat yield decreased 16% compared to no exposure. Feed intake increased 5% for cows exposed versus not exposed. Lower fat secretion and increased appetite suggest EMF may have caused cows to be diabetic from lack of insulin to support glucose across cell membranes of mammary glands. EMF caused adrenal stress in cattle at Cornell University. Cows subjected to 4 and 8 milliamperes current, and this was contact current, before, during, and after milking, had increased cortisol in blood, increased heart rate, and increased blood pressure, as reported by Gorwit et al., Cornell University, at the Stray Voltage Symposium in 1984. EMF affects the pituitary gland at the base of the brain. This was more evidence of the stress syndrome in the Cornell experiment. Oxytocin release was delayed with electrical exposure. Delayed release inhibits milk excretion from the udder, resulting in incomplete milking as observed by farmers. Retained milk increases bacterial incubation in the udder, according to Dr. George Main at the University of Wisconsin. Increased somatic cell count in milk and mastitis in cows was a common complaint of farmers with uncontrolled voltage. Erythrocyte micronuclei of blood cells were 6 times more frequent in cows housed in front of a radar station than controls in a remote location in Latvia. Micronuclei are a test for chromosome damage, indicating genetic damage from electricity. Cows and humans live in the same environment on farms. Cows are similar to the canary in a coal mine. Leukocyte subpopulations indicated absolute numbers and ratios of CD4 divided by CD8 lymphocytes suggest a cytotoxic effect of CD8 plus microcells. The effect was only seen in cattle exposed to 1.98 to 3.28 microtesla magnetic fields of cattle housed 7 meters under a 375 kilovolt transmission line compared to a remote herd in Italy. The blood studies were performed by pediatric oncologists at the University of Padova Medical School. In summary, physiological effects of EMF on cows include 1. Increased adrenal output of cortisol, heart rate, and blood pressure by stimulation of peripheral nerves, delayed release of oxytocin from the pituitary gland, decreased melatonin from the pineal gland, length of estrous cycles increased, insulin-like growth factor, IGF-1, increased in blood, growth hormone was modified during part of the nocturnal cycle, macro and trace mineral changes occurred in blood, calcium, magnesium, iron, and copper. Cerebrospinal fluid electrolytes changed in concentrations of calcium, phosphorus, magnesium, manganese, and sodium. Quinolinic acid, a precursor of melatonin, increased in cerebrospinal fluid. Tryptophan, precursor of serotonin, increased in cerebrospinal fluid. And erythrocyte, micronuclei, and lymphocytes were modified by EMF as in erythrocytic and lymphatic anemia. Installation of a shielded neutral isolation transformer between utility power supply and dairy farms reduced radio frequency EMF to near zero and allowed performance of damaged herds to return to normal after several months of recovery. Isolation of farms by moving the transformer pole from the barnyard was helped in some locations. EMF radiated from overhead lines can be reduced by engineering determination. Capacitive filters tuned to the prevailing frequencies can reduce EMF in the living environment. I am grateful for the extraordinary effort of my colleagues listed here and to Mark Farron, who assisted in editing the script. That concludes Part 1 of Electric and Magnetic Fields in Homes, Schools, and Workplaces.